Let me introduce our speaker, Ms. Maureen O'Kane. Anyway, she's an interesting speaker. She is, she does live up in Linden with her husband Roger, and of course that's where all good Dutch people live. And but she tells me that she used to believe in evolution, and she didn't come to faith until she started to read the Bible for the first time at the age of 25. So she has a passion to provide a more complete image of our Creator. Maureen has shared scripture science programs at schools, campgrounds, churches, and conventions. The topic that she's going to speak on is called Do the Math. Let's do the math. And the basic question is math invented or is it discovered? And you can see the aspects that she's going to, we'll see the aspects. So let's welcome Maureen.
Okay, thank you. Thank you. Thank you for that introduction. So what I'm going to do is first establish what mathematicians from decades ago and now say about math. So we're going to establish what math is, and then we're going to look at the math brains in creation. And I think you'll be surprised at some of those. Okay, so do the math. This is the greatest equation in the universe. 3 + 1 = 4, and I did not misspell 4 in parentheses. And at the end, I'll tell you what that equation is. There we go. So the big question, were mathematics invented or discovered by man? If invented, is this too close to my mouth? If invented, then the language of the universe was created by humans, if you can imagine that. If discovered, we must acknowledge intelligence developed a language that we can understand. So when did our interest in math begin? Our world is made up of patterns and sequences. One of the reasons mathematics began was because we needed to find a way of making sense of these natural patterns. So you've got the phases of the moon, with flowers, of course, spring, fall, winter, migration. Most basic concepts of math, space, and quantity are hardwired into our brains. This was very disappointing for me to hear because I would always say, well, I don't have a math brain. And now that's not true. Even animals have a sense of distance and number. Assessing when their pack is outnumbered, think about that. 2 wolf packs get together and they can count. Oh, they have more than we do? How are they doing that? Whether to fight or fly, whether their prey is within striking distance. When I grew up in Southern California, we had a lot of rattlesnakes, and they coil up before they strike. Well, so that's what's going on in that reptile's brain is, okay, she's 2 feet, but a little too far, or she's that's amazing to me, that they are figuring that out in their brains. Never thought of animals doing that. So when did math originate? The earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. We have water molecules without order, recognizable shape, or observability, right? So now I'm going to replace some of those words with the original Hebrew. The earth was confusion, a place of chaos, and empty, and dark obscurity was upon the surface of an abyss of surging water. Wow, sounds awful. Now, since math is about patterns, sequences, and predictability, and God created math, we're going to find out it's his language, he used math to change that chaos into order. The unknown into recognizable patterns, and obscurity into predictable sequence of evenings and mornings, which we call time. So does God use math? The very hairs of your head are numbered. Now, how many of us care? Well, my husband's going to say he would care because he's losing his hair. But for those, most of us really don't care to know how many hairs we have, and yet it matters to God because we matter to him. He even knows how many hairs are on our head. Should I? Yeah. Okay. Does he not see my ways and count all my steps? Even our steps matter to him. Since his days are determined, the number of his months is with you. He knows our lifespan. You number my wanderings. put my tears into your bottle. Number my wanderings. This word for wanderings is only used here in this one place in all of Scripture. And it means the wandering of an aimless fugitive. So that's a time when we leave God. And I would think he would say, I put my tears, God's tears into the bottle. And here he puts our tears. We've left him. We're wandering aimlessly. And of course, a lot of us have had that point where we feel very alone, unwanted, uncared for. And he puts our tears, he marks each time we are a fugitive. Yet he has made with me an everlasting covenant, ordered in all things and sure. And that word ordered is to set in a row, arrange. There's the sequence, there's the math. There's even math in the covenant with us. Wow. So, he is before all things, and in him all things hold together. He holds the bonds of atoms, and we find order. And this is through a scanning, tunneling microscope. So here's iron atoms on copper. And you can actually go to a website that has all these amazing pictures. And then here's on a nickel. And look at, it looks like, like soldiers all lined up. Look at the order. And that's what the scientist said is how orderly that is. So when did humans begin to use math? Then God, brought him, this is when Abraham was Abram, outside and said, look now toward heaven and count the stars if you are able to number them. The Hebrew word for count in number is safar, and we get what word from that? Cipher. Remember the old term for counting? Safar means to score with a mark as a tally or record, to enumerate, to inscribe. Abram is the first to be told by God to physically inscribe, tally, record the number of stars. But why him? Where did Abram grow up? There you go, which is Babylon. We now know that Babylon was ahead of Egypt and the Greeks. Plimpton 322 clay tablet reveals the Babylonians understood geometry, algebra, trigonometry, and fractions. We did not know that before we found these. 400 clay tablets reveal Babylonian math remained constant for 2,000 years and was superior to Egypt. Plimpton 322 proves they used trigonometry 1,000 years before Hipparchus, a Greek mathematician known as the father of trigonometry. The Babylonians were already way ahead. So God did not randomly ask any human to count the stars. There was a reason. It was Abram, because he could do the math. So God has purpose behind his plan. So remember that when he asks you to do something. Okay, there's a reason he's asking me. So Abram could do it. So how did the founders of modern science view math? So this is Pythagoras. He says there is geometry in the humming of the strings. There's math in the music. And he's right. And I'm not musically talented, but for those of you who are, this is about ratio octaves, ratio octaves. Anyways, on a guitar. So it's all about how there's math in the music. And then he says, so he's saying there's math in music, and now he's saying there's music in the spacing of the spheres. There's music in the math. But the telescope would not be invented for another 2,000 years. How did he know there was a mathematical formula in our solar system? Unless the maker of the solar system and the maker of math and the maker of music told him. Right? Okay, here's Galileo. Mathematics is the language which God has written the universe. They saw it. He was an astronomer, a physicist, and a mathematician. He said it is written in mathematical language, and the letters are triangles, circles, and other geometrical figures, without which means it is humanly impossible to comprehend a single word. It's written in a language that God wrote, and we're made in his image, and we can see, we can understand. Here's Kepler. Where there is matter, there is geometry. Who was good in geometry and who was good in algebra? And who was good in both? Right? Oh, you were good in both. I admired people that were good in math. Some people struggle. I was one of the ones who struggled, but good for you. Geometry is one and eternal shining in the mind of God. That share in it, according to men, is one of the reasons that man is the image of God. So Kepler understood that's how we could read it and understand it. And here's Isaac Newton, considered probably one of the most brilliant people of all time. Gravity may put the planets into motion, but without the divine power, it can never put them into such a circulating motion as they have about the sun. He saw the harmony and the beauty. All variety of created objects which represent order and life in the universe could happen only by the willful reasoning of its original creator. And in 2 years, Isaac Newton, he came up with a new theory for light, the law of gravity, and calculus. In 2 years. I guess he had some downtime, and he invented these amazing things. So is there a connection between math and the arts? This is Alfred Whitehead. He said, "You may fly to poetry and music, and quantity and number will face you in your rhythms and your octaves." So he's saying, again, math and music, interchangeable. Here's G.H. Hardy. "The mathematician's patterns, like the painters or the poets, must be beautiful." I never thought of this when I was learning math, that it was beautiful. I never thought of it with poetry and music. So this study has just changed my mind about math, or it's changed my attitude. The ideas, like the colors or the words, must fit together in a harmonious way. Now, Bertrand Russell is an atheist. I think he's the one that wrote the book, Why I'm Not a Christian. But when I say these words, does this sound like the words of an atheist? The true spirit of delight, the exaltation, the sense of being more than man, which is the touchstone of the highest excellence, is to be found in mathematics as surely as in poetry. I think, even if you don't believe in God, you can be impressed, inspired, admire his works. Like, here's people that are still moved by it, even though they don't acknowledge the creator. There's something to what God has made that moves them. Simple abstract equations describe complex physical things. Look at that. Simple, abstract, complex, physical. Beautifully and elegantly. Why should this be? It's only with God could this happen. This is Marcus du Sautoy. He is a professor of mathematics at Oxford. Rhythm depends on arithmetic. Harmony draws from basic numerical relationships, and the development of musical themes reflects in the world of symmetry and geometry. So he brings together once more the music and the math. So does God use math's music to inspire and instruct? Here's Moses. Now therefore this is God telling Moses, "Now therefore write down this song for yourselves and teach it to the children of Israel. Put it in their mouths that this song may be a witness for me against the children of Israel." And you've read the song, right? In today's genre, it would be a country western song. It's all about those cheating people that are going to leave him. And it's sad, but it's just like we're still singing those songs, right? So the people shouted when the priests blew the trumpets. This is when they're going around Jericho. King David, the shepherd king, was a type of Christ. His psalms and songs speak for us and to us even today. It spans a couple thousand years. And when King Jehoshaphat had consulted with the people, he appointed those who should sing to the Lord and who should praise the beauty of holiness as they went out before the army. Can you imagine if we sent out an army? Roger was in the army and sent to Vietnam. And imagine if a choir was sent to be with the army and they go before. So the soldiers, as they're marching, are being what? What would it mean to have them singing about God in front of you? Right? Would it be strengthening, encouraging, or you wouldn't care? But I thought, wow, to me that's a beautiful picture. About midnight, Paul and Silas were praying and singing hymns to God, and the other prisoners were listening to them. So God's music of math, it inspires and encourages and strengthens us. So what do today's mathematicians say about math? So this is Arthur Benjamin. A lot of homeschool kids know him. He says he teaches Mathemagic, which is just shortcuts to do in your head for math, and the kids love it. And he says math is used to learn calculation, application, and inspiration. So calculation, simple counting, something we all do. Application, personal, computer, cell phones. Computer program, zeros and ones. Social media. Do numbers figure in social media? How many likes, how many friends? YouTube, subscribers, right? They get so much money if they have so many subscribers. Global, we have trade, loans, all that's math. But I love this one, inspiration. the beauty in nature, art, and literature. I never thought of math in that way, and here, God's language is right there. So here's Marcus de Sautoy again. He's a professor of math at Oxford. He calls mathematics the language the universe is written in. It's a language. Here's Dr. Randy Palisak. He was an award-winning teacher in 2014. He says math is a human language because it allows people to communicate with each other. We can all understand it. And this is Eugene Wigner, and he was harshly criticized when he said this in another quote. The laws of nature must have been formulated in the language of mathematics to be an object for the use of applied mathematics. Excuse me. Here. Because he also said it's a gift, and he called it the miracle of math. And he said it's a gift we neither understand nor deserve. And his atheist friends said, don't be bringing up miracle. And he did. So again, here was someone who was moved by what God has made, even though he did not know God. And I pray he did before he died. So according to our dictionary, language is a systematic means of communicating ideas or feelings by the use of conventionalized signs, sounds, gestures, or marks with understood meanings. So for people here that are veterans, when a message is sent but not received, what's the point, right? It's no good. So it's message sent and message received and understood. That's the goal of communication. Without meaning, words are just ink on paper, chemistry on matter. So here's Philip Lieberman. Speech is so essential to our concept of intelligence that its possession is virtually equated with being human. So right there, intelligence goes with speech. And math is a language, and you have to have intelligence for the language. Here's Noam Chomsky. Human language appears to be a unique phenomenon without significant analog in the animal world. So we're the ones with the written speech and the written language and spoken language. He wrote a book in 1957 that actually changed the science of language. And it was based on, I'm going to go a little ahead here. In 1983, Nicaragua had a deaf school with 400 students, and they were not able to learn Spanish or lip reading. But outside the classroom, unbeknownst to the teachers, the kids had developed their own pidgin language of gestures and signs. And this is how now the language taught deaf children in Nicaragua, but it proved Chomsky's theory that language is actually innate, with emphasis more on the meanings than the mechanics. Here, I'm going to go back to this. This is what Noam Chomsky said. The innate ability of children to acquire the grammar necessary for a language can be explained only if one assumes that all grammars are variations of a single generic universal grammar, and that all human brains come with a built-in language organ that contains this language blueprint. It used to be that it was believed before he wrote his book in 1957, that language was learned. Babies grew up hearing their parents speak, and so they just mimicked their parents. But he's saying, even if they can't hear their parents, we are wired to communicate and to understand each other. So let's summarize what we just learned. Experts call mathematics a language. Intelligence is essential to produce language. Our ability to learn language infers a built-in language blueprint that emphasizes meaning. Does Scripture offer any clues to this built-in language? In the beginning was the Word, and the Word was with God, and the Word was God. That's logos, is a spoken word with meaning and motive. The unfolding of your words gives light, it gives understanding to the simple. This is my prayer. Lord, give me understanding, because I am simple. I no longer live, but Christ lives in me. For who has known the mind of the Lord that he may instruct him? But we have the mind of Christ. We have that blueprint to understand him, to seek him, to recognize him, to know him. He wants to be known. So let's do the math. Okay, prime numbers, building blocks of all numbers, because every number is built by multiplying these primes together. So every other number has to be multiplied, uses prime numbers, but the pattern behind primes has yet to be uncovered. So there are 37 trillion cells in the average human body. 37 is a prime number. How is that a coincidence? Italian mathematician developed a sequence known as the Fibonacci numbers. They appear in mathematics, computer algorithms, and nature. Each number is the sum of the two previous numbers. So you got 0 and 1 is 1, 1 plus 1 is 2. You can see it's in our bones, the flowers, the galaxies. Within our cells, the DNA molecule measures 34 by 21 angstroms at each full cycle of the double helix spiral. Those are Fibonacci numbers. Again, what are the chances? So here's information. Okay, so in Gibraltar, there's a cave, and some people in 2014 found what looks like a hashtag, and they said, oh my word, humans were here. And this is either art or a word, and it's just a hashtag. So it could have been some kids just scratching in the rock, but anyways, it's now Neanderthal cave art. And yet DNA, a 3 billion letter word or a numbered digital code, is not considered language? But a hashtag on a rock? In biochemistry, each protein consists of a string of chemicals which are letters in a book, and this is at Dr. de Sautoy. But to read this language, so he's an agnostic, so he's admitting that with DNA, but to read this language and predict how the 1D string will fold up in 3D space, you need a mathematical dictionary. We can't, apparently we couldn't figure it out. So he's saying there's so much more. DNA has been an eye-opener, right? When it came on the scene between creation and evolution. Because, and this is from Andrew McIntosh, who has spoken here, because no advanced thinking can be allowed, there is no way nucleotides can arrange themselves in a predefined code. So a code that's already existed from who, where? Since this assumes prior knowledge. Okay, DNA's proteins were assigned to a musical scale. Would a pattern emerge? And Richard is going to help me with this. So remember, these proteins were assigned random instruments and notes. And take your time, this is a friendly group. Okay. Yeah, the first one's going to be beta globin. Do you hear a pattern? Do you hear a melody? Do you hear a tune? Okay, go ahead and turn that one off, and then go back to that AQ, this one's simpler one, AQ accordion. Yes, you go back twice, and then AQ, it's below beta globin. Here it is. So even the more simpler one, you still hear a pattern, right? We recognize it as music and math. Thank you both so much. Thank you, Richard and Dad. I don't know Richard's dad's name. Bill. Thank you, Richard and Bill. So all of creation, including music and poetry, is built on mathematics, which applies to even the tiniest molecules. So, this is Sir Fred Hoyle. He's an astronomer. The likelihood of the formation of life from inanimate matter is 1 to a number with 40,000 zeros. It is big enough to bury Darwin and the whole theory of evolution. Here's a guy. So he's an atheist, and his last name is Haldane, and this, what he's going to say, is called the Haldane Dilemma. British geneticist and atheist evolutionary biologist J.B.S. Haldane on evolution of humans. The number of genetic deaths needed to secure the substitution of one gene, so how many would, as the gene is mutating to become a human, how many false starts or dying of the one with the bad gene until it gets it right, he found out a formula. By natural selection is in the region of 30 times the number of individuals in a generation. So we came up with a formula, which means this implies some 150 billion forerunners of modern man lived on Earth. We're not even to 8 billion now, and it's pretty crowded. So 150 billion, but where is the evidence in fossils and tools for these vast numbers of primitive humans? I mean, where are they? Imagine 100. Here's evolutionist Stephen Jay Gould. He stated that even if evolutionary history on Earth repeated itself 1,000,000 times, he doubts whether anything like Homo sapiens would ever develop again. He concluded that humans are, and again, he sounds like a Christian, except for the one word, you'll see, glorious evolutionary accident which required 60 trillion contingent events. I mean, he's admitting what it took to have us evolve. It's impossible. And they're saying it, the other side. They're admitting it. So here's chemistry. Russian chemist Dmitry Mendeleev used mathematical patterns he discovered in the chemical elements to create the periodic table, the fundamental tool of chemistry. Now, Dmitry, when he lived in Siberia, and when he was 13, his dad died. And his mom said, okay, she wanted him to go to school. So she moved the family, and think of Siberia, and back in those days, she moved with him to Moscow and to let him go to college. And while he's in school, his father's died at 13, and just a few years later, they're in Moscow. He's in school, and his mom dies. I know of TB. He would contract it but not die. Anyways, he was raised a strong Christian. And as he was sleeping, he suddenly saw the elements all lining up. And when he woke up, he wrote them down. And his genius is in that he left empty spaces for things that would be discovered. Now, if that's not from God, right? Because how would he know? God gave him this beautiful vision. I mean, talk about the father to the fatherless. Here's a young man that should have probably felt all alone in the world and just gave up, but God was with him, and God gave him something that affects us today. Mendeleev dedicated his Principles of Chemistry textbook to his mother, quoting her last words to him: refrain from illusions, insist on work and not on words, patiently seek divine and scientific truth. She totally got it. God and science go right together. No problem. Here's plants. So here's the golden ratio, is also called the Fibonacci spiral. So you can see that beautiful spiral this is so fiddleheads. It looks like a cabbage, sunflower, pine cone. So as plants grow, now think of it, you're walking through a field, you're walking through the woods, and you pass all sorts of plants, and we don't even give this a thought. But as plants grow, the leaves average 222.5 or 137.5 degrees from the previous leaf. That detailed in plants we walk by, maximizing space and light for each. Spiral pattern allows for center of gravity to remain constant as the plant grows. But even the leaves have a specific space. The Venus flytrap. In my house, we have a few carnivorous plants because I hate when I kill a fly, it's all icky, and then you got to clean the window. And so now when I hear a fly, I'm just like, oh, it's just going to be a few minutes. It's going to be zip. And so I highly recommend them. So the Venus flytrap has sensitive hairs, and I don't know if you can see at the bottom, you can see, so it looks like little whiskers or little white hairs between its leaves with a built-in timer, and scientists still cannot explain it. Like, why would this have a specific timer? And its timer is exactly 20 seconds. Not 22, not 18. So the insect touches one of the hairs, and the 20-second timer begins. You know, the clock is ticking. Another hair has to be touched. That ensures the plant that this is a live, prey. They don't eat dead things. It has to be alive. So if it's moving, it's alive. So the second hair is touched, and it has to be touched within the 20-second timer. And then the trap closes. And then as the insect does this, the digestive enzymes are released. So the timer to make sure it's live prey. Again, talk about design. It's incredible. When I have brought my fly trap to schools, of course all the kids want to feed it, and so I have to catch some flies, and this is going to sound terrible, but I rip off one of their wings so they don't fly away. So anyways, the kids hold it and they feed it, but they think those, what looks like teeth are, like teeth, and so I tell them it's soft. But anyways, when they put it in, then we shine a light and they can see the fly doing this, saying, yeah, like that mime guy. And it's just, it's incredible that this plant, it's unique in all the world. And it only grows in a little bog area, North and South Carolina. Only place in the world it grows. Yeah. So researchers once believed plants break down starch at a fixed rate during the night so that 95% is used by dawn. This was fascinating. I can no longer say I don't have a math brain, because plants don't have a brain, and they can do math. So Arabidopsis is a humble mustard plant. was observed recalculating that rate when randomly subjected to 16-hour nights. So here's this big warehouse, and the plants are given 12 hours of light, 12 hours of dark. And when you measure the starch just before dawn, there's only 5% left. And so when it's photosynthesizing, it's making sugar and starch, and the starch, a certain portion of starch is kept for the night, because plants still are alive at night. They've got systems, and so those need to be fed. So they put aside the starch, and of course, for this experiment, the plants were used to enough starch for a 12-hour night. And how did they know what a 12-hour night was? Think about it. Okay, but then these mean humans turned off the light 4 hours early. So it now cannot photosynthesize anymore. And now it's facing a 16-hour night, which of course it doesn't consciously know. It limited the amount of light to make the starch. So the plants adjusted immediately. They did the math. And so here's the scientist said, these dynamics require an arithmetic division computation between the starch content and expected time to dawn. We introduced 2 novel chemical kinetic models capable of implementing analog arithmetic division. So if you look on the right, you've got the starch divided by the length of the night. So it has to anticipate. So what it does is it starts degrading the starch within it at some ratio to how long the night is anticipated to be. But you're thinking, well, they could be off by an hour, 2 hours, right? It's a plant. But they are right on. And so with the 16-hour night, they measured the starch, 5% left. Like I said, we have no excuse, people. Here's the roots. So the roots of that same plant, the Arabidopsis, can grow in agar, allowing us to watch how its roots grow. And these are just, it's beautiful. So when protons flow into the cell wall stretches and the root tip then grows a little. But then the plant cell pulls back the protons immediately, and the cellulose strands, they lock in place to strengthen the wall. Pause and repeat, resulting in root tips pulsing every 20 seconds. Just like the Venus flytrap, it likes those 20-second increments. The chemical regulation, this is a scientist, botanist, this is what he said. The chemical regulation of these pulses is highly complex. Everything is coordinated. It is like a dance with the entire complicated ballet occurring up to 3 times per minute. He is fascinated with this. Yeah, I think when you get into God's creation, you reach a place where there's no words to explain, or there's no reason unless you bring God into the equation. Okay, slime mold. Who here has laid down mulch and saw slime mold appear? It looks like usually yellow. It's eating your mulch. Okay, I mulch like every other year, and sure enough, here comes the slime mold. Well, I always thought it was just this annoying thing eating my mulch that I paid for, so I would get the pitchfork and throw it somewhere else. But then I read that there was a man who was a slime mold expert, and he had spent 70 years studying slime mold. How fascinating can it be to keep you interested for 70 years? And I thought, well, okay, there's more to slime mold. And there is. You're never going to look at it the same again. In fact, when you see it on your mulch, you're going to go, oh, cool, I've got slime mold in my garden. People, do you want to come see this? This plant can do the math. No brain, no eyes. Here it is. Slime mold are single-celled organisms that can live independently or join together to form multicellular reproductive structures. They send out a signal, but again, no mouth, no ears. They're sending out a chemical signal that the others are hearing, and they start gathering. Certain time, they just start coming together to make, so these are each little single-celled, and as they grow, they just keep dividing their nucleus. They come in a variety of colors and patterns. In fact, one type resembles dog vomit, and it's called the dog vomit slime mold. And of course, how does it know what dog vomit looks like? How does it know to put that color and that shape? Think about it. These are the pretty ones. I didn't think you'd want to see the dog vomit one. And the one on the left, the yellow, that's the one that usually appears on your mulch. Okay, slime mold. They can do the math. So here it is. They will quickly find the most efficient way through a maze to reach food. Turns out they are very healthy eaters. They love oats. So you've got the slime mold at the top and an oat in the middle, and you can see it's sending out its little like branches, and then once it sees a dead end, it immediately pulls back and so now I'm going to show you how this can be applied. On the left, in 5 hours, so this is Tokyo, is the big yellow dot on the left. And the slime mold was just placed there 5 hours ago. And all the oats around there are the surrounding towns around Tokyo. So it's already begun to eat some of them. Oh. Somebody's got their phone on. Oh, there you go. Thank you. So 5 hours, and then 16 hours later, it has now found the most efficient way to all those urban centers around Tokyo. So what could we use this for? On the left, you'll see the slime mold network for Tokyo, and then below is the actual Tokyo railway network. And then look over to the right. There's London, or UK. So think of the millions of dollars cities can save if they don't hire the architects, the engineers, and the city planners. And you could bid against them saying, yeah, I'll do it for $5,000 instead of millions, and I can do it in 24 hours. I just got to go feed my slime mold some oats, and I'll have the plan back. Isn't that something? So here's what they said. This was Live Science. It says slime mold beats humans at perfecting traffic network. It says the work provides a fascinating and convincing example that biologically inspired pure mathematical models can lead to completely new, highly efficient algorithms able to provide technical systems with essential features of living systems. Slime mold. Like, are you all impressed with slime mold now? I mean, come on. Yeah. It can do the math, it can do mazes better, faster than humans probably, but I thought that was fascinating that it can determine networks for traffic, for either buses or trains. All right, insects. From a mathematical and engineering perspective, hexagons are one of the best shapes of construction. So these are butterfly eggs as seen through an electron microscope. Aren't those gorgeous? And these are tiny little eggs that we wouldn't even notice. They're usually up beneath leaves. And so God puts this incredible beauty and design in things that we'll probably never see. But he's doing the math, right? The beauty. Australian stingless bees, I like that, store their honey and brood cells in a golden ratio spiral comb. So, flying math. Now, my dad was in sales, and so he would joke about the traveling salesman dilemma. Well, guess what? Bees have solved it faster than humans. So basically, you know what it is you've got your home base, and you've got several cities that you have to visit, and and they're all different places, different distances between them, and what's the most efficient way to go visit all of these cities with least amount of time and travel? So researchers at the University of London placed tiny radar transponders on several bees, which I'm sure they appreciated. Look at they just... Then they set up 5 stations with nectar in the fall when nectar was rare, and each station provided 1/5 of the amount the bee could carry, motivating it to visit all 5 stations. So there's where it's going to figure out how to get to the 5 stations in the most efficient way. Here it is. It shows that bumblebees with their diminutive 1 milligram brain, size of a grass seed, are capable of finding nearly a perfect solution with relatively few attempts. 20, they got it in 20 out of a possible 120 attempts. They got it in 20 or less, and in a relatively short time. Wow. And here's the man that was part of that research. This is when he announced it. When they have a finding, they announce it on either YouTube, well, you see it on YouTube or TV. Before this study, such sophisticated learning was thought to be something only larger-brained animals were capable of. And now they know. So there, it starts to tear apart the thing about primates, from primates to humans, because it just seems logical that, they're the smart ones. Well, nope, the bees. The bees beat them. So here's the cicada. It's equipped with a timer and a thermometer. Every 13 or 17 years, prime numbers, they emerge. And they're in the east and south. Now, has anyone heard them? Has anyone been in the, okay. And so we've been in, Roger's from Nebraska, my family's in Virginia and Carolina. They have different sounds. Like the Nebraska cicadas are way different than the Virginia. And so they actually developed their own language to communicate with each other in that area. Now, do you like them? I think it looks cool. They're little exoskeletons, marching up the tree. All right. So, we've been hearing about driverless cars for a few years, right? And does that keep you up at night? It's like, are they kidding? Well, turns out the ants, they're going to go to the ants. Remember King Solomon, go to the ants, you sluggard, consider her ways. How did he know worker ants were female? Unless the maker of ants told him, right? Consider her ways. Well, you're going to find out. So, this is the headline. This is from the University of Sydney, Australia, taking traffic control lessons from ants. Okay, so ants move in two-way traffic patterns like people. So look at the middle lane. So you've got army ants at the top, leaf-cutting ants at the bottom. And so with the army ants, you see the soldier ants are marching back to the nest in the middle, and then the other two are marching out for food. Leaf cutters, you see them bringing pieces of leaves back in the middle and going different ways. Well, the ones that don't have leaves in their mouths, they're the officers. This is so cute. It's the little ants. I don't know if it's the bossiest ant just gets to do that job, or they actually, make this ant the officer. But when congested, traffic officers will block ants from leaving the nest, because, the freeway is full, or they will force the ants to go around them, which changes the traffic flow. Now, I went and watched let's see, what's her name? Dusator, yeah. She's a kick. Her office, it would be so much fun. She's got everything set up for ants. And she's got little obstacles and playgrounds and challenges for them. And so she was talking about these officers. And so she's filming them. And you can see them. You see all the ants, busy, busy, busy. And then you'll see a couple like this, looking around, just kind of watching. You think, oh my word, they really are little patrolling ants. And then every now and then they'll go like this and stand in the freeway, and then the ants all have to start going around it, and it just slows it down enough to keep it going. I know. Why didn't we think of this? So we should, park cars in the freeway so people are going around, right? Slow down people. So what's interesting is scientists tried for 8 years to create traffic jams with ants. I would have stopped at 1 year, but apparently these scientists were determined. 8 years to try to create traffic jams with ants. The humans failed, the ants kept marching. So, when opposing streams of leafcutter ants share a narrow path, they instinctively alternate flows in the most efficient way possible. Studying how ants manage this could provide the basis of a system of driverless cars. You know what? I'm going to have to put my glasses on. Driverless cars running on ant traffic algorithms. We can't even, putting those two together, it's unbelievable, right? Okay, but there's something else ants can do that we can't. Ants build amazingly complex and stable structures. So this is a casting they just filled an ant nest in Florida, just to give you the idea of how high or deep they can go. This is a 6-foot-tall man. And you see the tunnels, so you see obviously at the top is where they go in. And then there's all these tunnels with these parts, horizontal parts. Those are spaces, chambers for the queen, for the eggs, for food. And Roger and I, when we went to Victoria, BC, they have the insect zoo. Oh, I have to go there every time we go there. And they have an ant nest, but it's all these pipes and see-through pipes, and it's all across the whole room. And these particular ants have a little cemetery. Isn't that cute? And so you follow them along, and you see all their rooms for something. And then when you get to the end, they built a slope. So when they bring the little dead ant, it just rolls down to the bottom. They don't bury it, they just roll it down the hill. But it was just so cute that they actually came up with a room for those that had died. I found that very interesting. Maybe I'm spending too much time with the ants. Okay, so here's what's fascinating. Ants build these tunnels. They have 1 million citizens, and it's strong, and there's no cave-ins. And humans, when we mine and build tunnels, what happens? We have a lot of problems, right? Either explosions. Okay, so that's what Jose Andrade at the California Institute of Technology and his colleagues set up miniature ant colonies, because he started thinking about that. Since we're exploring other planets, planning to move there, which count me out, but anyway, but they're going to be doing mining. That's what they're planning. And so they're thinking, well, let's go to something that has mining down. They figured it out. So the position of every ant in every grain of soil, that was the key, was captured by a high-resolution X-ray scan every 10 minutes for 20 hours. Yes, and this is fantastic. This is what they said. The ants somehow managed to stumble upon soil physics. They don't stumble upon soil physics. God wired them to understand it. So what it is to form arches, now they're not building arches. Like when we build a mine, we're putting up the structures and creating the ceiling. They just start digging, but they move the grains of soil in a way, and you can see, so on the left is the forces here. Let me do this next part. The forces on the grains, which are in grains of soil, gravity, friction, and cohesion, okay? So without any ants in there, it's just intermingled. It's just, the soil has the different forces. But once they start doing the tunnel and they're removing the correct grains, they purposely know which grain to move. Now, when they first started studying them, they thought, oh, it's just random. It's whatever grain of soil comes out easier. That's what they thought. But then when they saw this, they're like, oh, my word, they understand physics. So when they did that, as they pulled the grains, the forces, and you see on the right, the forces start to wrap around the tunnel axis as the ants excavate it. Wow. And so there's a lot more pictures I could show you, but I tend to, keep it short for each part. But that's fascinating. So ants know soil physics. And here we still have to struggle with it. So now they're believing now this is so interesting, if the ants stumbled upon it, which means they were clueless and just figured it out, but here's the humans saying, well, if this behavior algorithm can be analyzed and replicated, why are they wondering if humans can figure it out? We're supposed, we're the smartest, we have the technology. Anyways, it can find application in automated mining robots on Earth or other planets. And that's a mining robot there. So that's going to run an ant algorithm. So the locusts have no king. This is Solomon. They have no king, yet they go forth, all of them, by bands. And bands is army ranks. And look at their spacing. So a lot of people thought that locusts are a different species than grasshoppers, but this is what happens. So the green, long-legged, weak-flying, solitary desert locust becomes the short-legged, strong-flying, black and yellow swarming locust. It actually is the same creature. And it happens because when they start congregating, then they start rubbing up against each other, and the touching releases serotonin, and it actually starts changing their bodies and their abilities. I know, interesting. So here it is. Crowds of gregarious locusts will suddenly decide to march. Look at, they're all facing the same same direction. But they do so without leaders. These aggregations form marching bands. He uses the same language that Solomon used about ranks, army ranks. That's what it looks like. And so here's some young ones. And isn't that amazing? They all turn at a certain mathematical tipping point. So Ian Kuzan, one of the top 10 young scientists in 2010, studies 20,000 swarming locusts in his Oxford lab. This is so funny. When I read the article, the reporter from Wired magazine had to go there, and they put him in like a hazmat suit and put, big giant goggles and a mask, because as he stepped in, remember, 20,000 locusts are free flying in the lab. And so and they're hitting him in his goggle and smashing up against his face. And he's thinking, oh man, how am I going to do this story? So he talked to Ian, and Ian said, at a second critical point, the clusters would become a single marching army. Haphazard milling became rank and file. Whoops. So here's what he did. Ian had, in the lab, picture a giant, well, it'd be small for humans, but like a NASCAR racetrack, you know how it's oval? So he had one for the locusts, and he has 20,000 of them. Okay, so it's quite big, it's this whole room. And so he collect, say 2,000 locusts, and he'd go 1, 2, and he's putting just one at a time. And then he'd get to a certain number, and say it was 2,000. And they're all doing this. And then all of a sudden, when that one number came, they all turned and started marching the same way. How did they weren't counting. How did they know that number had been reached? And they all had to turn. Their motivation is if they don't all march the same direction, same speed, they get eaten. So very strong motive to pay attention. So that's what happened. So the reason why study swarms is because when normal cells change, duplicate, and congregate, they can then swarm into nearby structures as cancer. So this is a big study. It's been going on for years about studying the nature of swarms and how these locusts, it changes. You saw it change their appearance. They became destructive. They went from being pretty harmless grasshoppers to destructive locusts that annihilate fields for miles. Okay, Darwin's bark spider was just discovered in 2009, It builds the largest orb web in the world, up to 30 square feet. And it's the size of your thumbnail. Tiny. And yet it builds, so how does it hold that much silk? BBC does a great documentary on this. This spider silk is 10 times stronger than Kevlar. And Roger you wore a Kevlar vest. Yeah, it stopped bullets. This is 10 times stronger. So when this was discovered and the silk was discovered, of course, now universities are getting grants like, we need to get a hold of the silk. I think we could make shoes out of it, or boots, or some, things that humans can use that won't wear out. But it only lives in Madagascar, and its webs span huge lakes and rivers. Here's what's amazing. There it is. So it's on that little leaf on the left, and it will kind of bring out its little bottom where it's got the little spinnerets, and all of a sudden it releases this silk. And it releases them, it's multiple strands, and every few seconds it crimps it to keep it from fanning out too much. So it's actually managing that, and it sends it out over 80 feet. So it can gauge distance and how much material needs to be made. Little spider, teeny brain, gauging distance and material. And it just keeps sending it out. When you watch the documentary, so the female, she does that, and finally it gets across the river and it connects. Well, there's another bark spider over there, and he's like, oh, hey, I don't need an anchor line for my web, I'll just use this one. So he starts climbing on hers, and she feels it. Now they're like 50 or 60 feet above the river. And she starts running along because she's got to see who's on her anchor line. And she sees him, so she runs up to him and then bites it, and then they both swing down because she broke the line. And boom, they both plummet, and then they both climb up. And then what she does, and this is what scientists were amazed at, because BBC was the first one to film of the spider. She then redoes the 80-foot silk. How does that tiny body produce so much so quickly? So because of that, before spider silks can be subject to genetic engineering for commercial applications, the complete protein sequence and their functions, as well as the details of the spinning mechanism, will require additional progress and collaborative efforts in the areas of biochemistry, molecular biology, and material science. That's how complicated that is. The silk of a spider in Madagascar. Yes. Okay, birds. Now you guys are going to know what this one is. What's that? Yep, there you go. And they look like they're going to collide, and people come out in the evening to watch this, and they have been studied. Look at that. They go right through each other. And they each stay with their own tribe. Okay, Giorgio Parisi, theoretical physicist with the University of Rome, led a research team to study starlings. Findings were published in Proceedings of the National Academy of Sciences in 2010. I know, it looks like a bird, doesn't it? One bird's movement only affects its 7 closest neighbors. Why 7? It's just one of those numbers that work in nature. Also works in scripture, right? A signal from a single individual can cross a 100-yard wide flock in a fraction of a second with virtually no distortion or diminution. So there's a signal from an individual, and they don't know what it is, but that's why you see them going this way, and then all of a sudden they go this way. Yeah, there's some signal given. And so it just goes, there's like this ripple effect. And this is what they compare it to. The closest statistical fit for this behavior comes from the physics of magnetism and describes how the electron spins of particles align with their neighbors as metals become magnetized. I'll put it in better language that we can understand. So here's starling flocks behave like flying magnets. To achieve their extraordinary coordination, starling flocks in flight behave mathematically like magnetized metals. Their formations don't just transcend biology, but span multiple physical phenomena. Wow, we went from spider being super spider, and now we got starlings as super birds. I mean, they span multiple physical phenomena, and we just see them as, annoying birds that are getting rid of some of the like bluebirds, they're kind of taking over the habitat of some of our native birds. But they're amazing. Okay, I love this. In New Zealand, there's a new mathlete in town. So up till this point, primates, mainly chimps, they could do the math, and it was kind of known, they had a certain percent of accuracy rate. So in New Zealand, somebody came up with the idea of, I wonder if pigeons are smart. I would never have thought that, but he did. So he brings them in. It turns out they can definitely count. They can count. So what they're to choose is they're to choose the group with less numbers. That comes first, and then they can choose the one with more numbers. So they have to be able to tell less from more. Okay? Pigeons have shown they can learn abstract rules. I know we just call them flying rats, right? And here they're smart. They can learn abstract rules about numbers, an ability that had only been demonstrated in primates. When the New Zealand scientists did this study, they sent it to the chief woman scientist that was testing the primates, but they did not say it was pigeons. They just sent her their test saying, was this done correctly? So she looked at it and she said, yeah, you're obviously testing primates. She said, and they told her, no, it's pigeons. They didn't want her to have a bias before she looked at it. So then, of course, she looked at it more closely and thought, it's done correctly. Chimps and pigeons both scored 75% accuracy. So if somebody ever brings up about we're like primates, say pigeons too. So here's reptiles. How do sea turtles find, isn't that the cutest little picture? How do sea turtles find the exact beach where they were born? Scientists have known that the turtles, like many animals, navigate at sea by sensing the invisible lines of the magnetic field. So you have longitudinal and latitude, east and west, north and south. But they didn't know how they were able to return to the spot where they were born. So two hatchlings, this sounds mean, but they got two hatchlings who had never been in the sea. And they brought them to the Atlantic Ocean and brought them to opposite sides. Same latitude, but different longitude. Because most creatures go with the latitude. So they were just curious, what are these hatchlings going to do? One headed southwest, the other headed northeast. The results demonstrate that turtles use a kind of bi-coordinate, they're using both longitude, latitude, magnetic map in position finding, like a GPS, an ability that has long been hypothesized to exist in animals but never before demonstrated. The precise way in which turtles' magnetic map is organized in their brain is not yet known. They're still a mystery. These sea turtles are amazing, but they said they're in the middle of this vast ocean. It's not landmarks like a human would look for. And they said they just know where they're going. And little babies that haven't even been in the ocean yet, they just go and they just automatically, their little GPS turns on and they follow the magnetic lines and they go where they need to go and then they come back to where they're born. Now, they said there's shifting of the magnetic lines, and when that happens, the sea turtles will also be so in other words, they go further down the beach. You know, they go with those magnetic lines. If they shift, then they shift their place where they're going to lay their eggs. Okay, mammals. So here's the golden ratio or the Fibonacci spiral, and look at these two. The equiangular spiral growth never changes its basic shape, keeping the center of gravity constant. I love how God puts it on their heads. Everyone can see. Look at this amazing spiral. Here's Mr. Pennings. For all you dog lovers, now you got one more thing I'm going to give you that you can brag about your dog. So this is Mr. Pennings. He's a mathematician and professor of calculus. This is Elvis, Welsh Corgi and demonstrator of calculus. They live near the beach, so after he teaches school, they would go down the beach and he would throw a ball for Elvis. Mr. Pennings observed and measured hundreds of ball retrievals by Elvis to prove he had an innate ability here's the calculus, for minimizing the time of travel to a target when the available paths were either jumping in the ocean or running along the beach, required traversing different mediums, which was water and land, at different speeds, run or swim. That's a lot. And here's what it was. Elvis and all dogs are naturals at calculus. So you can say that, well, my dog can do calculus. What can your dog do? Or what can your kid do, right? So here's what it is. A is where Mr. Pennings would stand, and he'd throw the ball where B is. So it's in the water. It's in the ocean. So Elvis would run to either D, get closer, because he could run faster than he could swim, or he would go all the way till he's at a right angle and go straight to the ball. And that was demonstrating calculus. Who knew? So here's a pianist playing for elephants. Now look at the foreground of the one moving the hips to the music. I mean, there's our future dancer, man. But are they moving to the music or the math? I just love that. And the other one's helping the man play the piano. Look at the head. Here's herds of cows. If anybody, there's people here that have been around cows, right? Okay, Roger and I both lived on cattle ranches, and they're not fascinated with humans. They can be mildly curious if you're standing by the fence, they kind of look over. But these run to you. There's lots of YouTubes where you've got a jazz band, polka. They love, for some reason, they love the accordion, which, right, that's kind of passe, right? But they still love it. And you'll see them. This little girl was playing, was it an accordion? She was playing some instrument. She's just, I think it's in Ireland. She's just sitting on the ground, and you see nothing. You just see, grassy field. And all of a sudden, you see these little bobbing heads. It's like a herd running towards her, and then stand there. And so she's playing for them. So this is what happens with them. They run to hear you play your music. And here's Juno the beluga whale, like the mariachi music. Isn't that cute? So the big question, was math invented or discovered? The big answer, both evolutionists and creationists believe plants, birds, and mammals existed before humans, right? They believe it was eons, we believe it was in the order that God created. Since these organisms demonstrate an innate ability for math, math must have been discovered, not invented by humans. And if discovered, both sides, right? We looked at the mathematicians from decades ago and now, and both of them believe intelligence is required for this universal language. So when Job questioned God, God pointed to his creation. What would he learn? He said, do you know the time when the wild mountain goats bear young? Or can you mark when the deer gives birth? Can you number the months they fulfill? Time, a measurement of math. Have you given the horse strength? He paws in the valley and rejoices in his strength. He gallops into the clash of arms. He devours the distance with fierceness and rage. Their speed and strength, also measurements of math. Does the eagle soar at your command and build its nest on high? It dwells on a cliff and stays there at night, and from there it looks for food. Its eyes detect it from afar. Distance, a measurement of math. Eagles can see a rabbit almost 2 miles away. That is like us standing on the top of a 10-story building and seeing an ant on the sidewalk below. Yeah, and they can see in UV, we cannot. So just really appreciate God gave them super eyesight. So Job's answer was, I know that you can do everything and that no purpose of yours can be withheld from you. Therefore, I have uttered what I did not understand, things too wonderful for me which I did not know. I have heard of you by the hearing of the ear, but now my eye sees you. He saw the creator of beauty, patterns, design, order, sequence, complexity, math. That's what he saw. God showed him that for him to see God's power. The greatest equation in the universe, 3 + 1 = 4. Here it is. 3 nails plus 1 cross, forgiven. 3 persons plus 1 human. For who? You. For what? Life. For when? Eternity. Why? Love. I'm going to summarize math. And Gerda, where's Gerda? Oh, there you are. Do you have the mic? Oh, it's right up here with Richard and Bill. So we're going to summarize what we learned about math. Okay, you ready?
I'm ready.
Okay. Math is a language requiring a mind.
For God.
Math's beauty is breathtaking and unexpected.
So loved.
Math is inclusive of all cultures.
The world.
Math reveals purpose and planning.
That he gave his only son.
Math is measurable and logical.
That whosoever believed on him.
Math has tangible, absolute results.
Should not die.
Math is unaffected by time.
But have everlasting life.
Isn't that beautiful? That what we learned about math ties right in with the greatest verse. And here you're going to see math more when you read these verses. How precious also are your thoughts to me, O God. How great is the sum of them. If I should count them, they would be more in number than the sand. Many, O Lord my God, are your wonderful works which you have done, and your thoughts towards us cannot be recounted to you in order. They are more than can be numbered. Thank you.
Thank you, Maureen. There's a lot more to math than we thought. Anybody want to go back to school and learn some more math? No. And the other question I have before we,
Sure.
if you have a question, raise your hand and I'll come around to it. But can we get an army of ants to fix our
Army?
traffic problem?
Oh,
here?
traffic.
Yeah.
Yes.
We have a real problem on 170.
I was going to say, every time we come here, we have to allow about 15 minutes to get off the freeway to this church. Yeah.
So raise your hand if you have a question for Maureen.
Oh, great. Oh.
My brother raises bees on Orcas Island, and I know that in the winter, he told me when it gets real cold, they go in the hive and they make a circle, and the circle moves, and to them, 1/8 of an inch is many, many miles. It would be many, many miles for us to walk.
Sure.
So what they do to keep warm is they maintain that circle, and the ones that are in the middle are warm, and they move out to the outside, and the ones on the outside move to the inside. Just a little something.
See? That's beautiful. Yes. Don't they also do it? That's right, it is mathematical. And don't they also do it with the cooling? Is the opposite? Do they keep the hive cool the bees are amazing.
Okay, are you all stumped?
No. I have a question for you. Are you more intrigued and inspired by God's creation? That's you.
Well, if there are no other questions, we will, again, thank you for your presentation, and I'm sure you'll be available to answer any questions that they may have afterwards. So, thanks.
You bet.
Okay, just to remind you, there are a lot of resources in the back there, and there's refreshments for you that you can nibble on while you peruse the book tables. Ron Payne will be back there, and he's the one that deals with the books. And if you have an interest in creation tours of any kind, Ron does some, and there are, Mount St. Helens, but there's also others that Ron is aware of. The basic creation training course that we have coming up. Dan is going to be one of the teachers there, and if you have any questions about the basic creation training course coming up next month with Mike Riddle and Dan, again, raise your hand, and you can ask him afterwards. And the third thing is the youth night. And Barry Bogue, another one of our board members, standing at the back there, you can ask him questions about that. That's going to be in Snohomish. All the details are on the flyer there. And so next month, as I said, we have Mike Riddle coming. And this is the topic that he is going to speak on, equipping youth for the battlefield. And what he focuses is one of his statements that I like is that the world is out teaching the church. They teach, and they have students for so many more hours than we do at the church, and they are doing a bang up job doing that. We need to do better to counter that. So that's what his topic is about. And of course his company, Creation Training Initiative, he's done a lot of teaching, and so that will be very interesting. And on the back table there are flyers for all of these events, and there's also an overriding flyer with all of Mike's schedule. Speaking from the 22nd to the 26th at different churches, you can see where he's going to be and what he's going to be teaching. So take advantage of that. I know most of you are on our mailing list, but if you haven't signed up and want to get mail to find out what's coming up, there's a sign-up sheet on the back table, and but you can also do it online, of course, anytime you want. And the other thing I just want to mention again, the way we support this ministry is through donations from people that enjoy this. And there are 2 boxes at the back of the church, one on the back seat there, and there's another one on the back table there, exiting here. So if you wish to contribute and help bring our speakers in, feel free to do that. So with that, let me just close up in a word of prayer, and we'll be dismissed. Father, we come to you just to thank you for your creation, for your math, which describes your creation exactly, and which describes animals, plants, and everything that we see in nature, Lord. And we just thank you for the pointers that you have given to us that we are able to discover using our mind. And we just thank you for your beautiful creation. Bless now each one as they part from here, and traveling mercies on the way back. In Jesus' name we pray. Amen.